Hello everyone. Today we're going to start with the unit 1 or module 1 in the battery management system. Unit 1 consists of battery technology and BMS. Today we're going to discuss about power module, battery, DC-DC converter, load and communication channel. Before discussing these BMS parts, first we need to analyze the generalized architecture of battery management system. Here, this figure shows the general structure of the battery management system. We have power module, battery, DC-DC converter, load, and monitor and control. We have the power module connected to the mains, which charges the battery. The battery supplies the power through the DC-DC converter to the load. And we can see monitor and control blocks are distributed across all the parts. And all these components communicate through a communication channel. So this overall structure forms a complete BMS. Now, what and all the factors affecting this BMS? So coming to that factors affecting, we have first is cost of the product features, battery type, and type of the portable device. The sophistication of a BMS depends on several factors. As I said, first one is the cost of product, where low cost products usually have simpler BMS, and high end products with the features like minutes left or SOC information requires more intelligence. And also the battery type affects the complexity of the battery management system. Now we can see here example, devices like cellular phones are charged daily, so they require more advanced BMS compared to the devices like shavers. More advanced BMS or intelligent BMS, but the devices like shavers, there will be a infrequent charging, so simpler BMS is needed. And after this, we are going to discuss about the power module and charging control. Here we can see the main goal of this power module is to convert the energy. Okay, the power module converts energy from mains or other sources into suitable charging energy for the battery. It performs two main functions. First one is energy conversion control, that is ECC. Second one is charging control, that is CHC. Okay, energy conversion control, which regulates output voltage and current, and charging control, which determines how the battery is charged. Okay, now here I have mentioned efficiency is important, where high efficiency is essential because increased temperature reduces the battery life. Okay, now depend upon this charging control, we have partitioned the power module into three parts, that is CHC in PM, CHC in portable device, CHC in battery pack. CHC is nothing but the charging control. Now one by one we are going to see this one. CHC in power module. Here in this configuration, the charging algorithm is inside the power module. CHC is inside the power module. The battery is simple and contains minimal electronics. Okay. Now coming to second category, CHC in portable device. Here you can see the portable device controls the charging using its microcontroller. This offers flexibility but requires intelligence in the desktop charger as well. DTC is nothing but the desktop charger. CHC in portable device, okay, where it's required additional DTC. Now coming to the third part, CHC in the battery pack. Here in this case, the battery pack itself contains charging, or battery pack itself control the charging. Each battery carries its own charging intelligence, but this will increase the overall cost. So among all three, depend upon the application, we're going to use CHC. Okay. Now coming to battery basics and battery types. Okay. Here we know that a battery stores electrical energy from an external source and supplies it to the load when required. And this enables the portable operation. Okay. Now we all know that battery is nothing but the series and parallel combination of cells. Okay. Now common chemistries includes nickel cadmium, nickel metal hydride, and the lithium ion. Okay. Now the cell is the basic building block of any of the battery system. Okay. A battery pack contains multiple cells. As I mentioned, it's a series and parallel combination. When connected in series, voltage increases. When connected in parallel, capacity increases. So, whenever we are using these chemistries to build a battery, the safety requirement is essential. Now, for example, if I'm considering lithium ion cell for the battery manufacturing, what and all the safety requirements are required, we'll see. Now, the safety requirement for lithium ion batteries, which include strict safety control. They must operate within the specified voltage limit, current limit, and the temperature limit. If voltage exceeds the upper limit, it may cause the fire or explosion. If voltage goes too low, it causes irreversible capacity loss. If excess current leads to the overheating or high current overheating. So these lithium ion batteries require strict safety control. And coming to this, here we can see I mentioned the title as voltage versus capacity versus cycle life. There is always trade-off between capacity and lifespan. Increasing the voltage increases the capacity. However, it significantly reduces the cycle life. Okay, here we can see, for example, 100 millivolt increase can increase capacity by 12%, but reduce cycle life by around 200 cycles. Therefore, the maximum voltage level is chosen as a compromise. That's why I mentioned here design is equals to the compromise. So, whenever we are using lithium ion batteries or any chemistries for the battery, there must be a safety and protection requirement. For that, we are going to use this electronic safety switch and the protection. inside the battery. Now here I am considering lithium ion battery pack. An electronic switch is integrated inside the battery pack. It continuously monitors voltage, current, and temperature. If any parameter exceeds limits, it disconnects the battery. It works similar to an intelligent fuse, but with controlled delay. Okay, where this is always connected inside the battery, it must consume very low standby current. Okay, now coming to the battery, we know that the battery is not a single cell, it's a multi cell. Okay, for that, we required a smart battery with those multi cell packs. In multi cell battery packs, what will happen? Cells are never identical. Okay, due to the manufacturing or aging differences, imbalance occurs. Right? The weakest cell determines the overall performance of the battery. So to solve this, supervisory ICs and charge balancing circuits are used. That may be a active charge balance or passive charge balance. Okay, when a battery includes monitoring, communication, and memory, it becomes the smart battery. Okay, here the lithium ion batteries require careful voltage, current, and temperature monitoring. Fine. Protection circuits and smart battery technologies ensure safety, longer life, and reliable operation. Fine. Now coming to the next part of BMS is the DC-DC converter. Okay. The basic task of DC-DC converter in any portable system is to match the battery voltage to the required load voltage. Here I have mentioned main goal is to match the battery voltage to the required supply voltage. If the battery voltage is lower than required, we use a boost converter. If it is higher than required, you use a buck converter. Now, whenever you are using the converters, the efficiency is more important. For that, the efficiency point of view, it is always better to convert the battery voltage to the minimum supply voltage required by the load. That we are going to call it as V minimum. Okay, operating the load at higher voltages than the necessary voltages, which wastes the energy. Also, the load can be designed specifically for V minimum for improving the efficiency. Now, what about the energy loss? Here you can see the total energy from the battery is proportional to V into I into T. If the battery voltage is higher than V minimum and we connect the load directly, the excess voltage is wasted as heat. But by using an efficient DC-DC converter, we reduce this loss and improve the overall system efficiency. Okay, therefore, DC-DC converters are essential in portable systems, not only for voltage matching, but also for maximizing the energy efficiency. Fine. Now we move to the load. Here you can see the load converts electrical energy from the battery into the useful energy depend upon the application. That may be mobile or laptop or etc. Okay, in portable system, different parts requires different supply voltages. Like digital circuit operate at lower voltages, while analog circuit often require higher voltages due to the signal to noise ratio requirement. So as IC feature size decreases, maximum allowable voltage also decreases. Now you can see here some application like LCD backlighting or a power amplifier requires special voltages, sometimes even negative bias voltages. Therefore, from a single battery voltage, multiple voltages must be generated using DC-DC converters. Now, what about the power consumption and how we are going to integrate the BMS into it? That we'll see in the next slide. Here, power consumption and BMS integration. The power consumption of the system parts can vary significantly, as all we know. For example, a power amplifier in a GSM model transmit in burst mode can draw up to 2 amperes. This requires a careful power supply design compared to the components that draw only milliamps. Since most the portable devices already contain a microcontroller or microprocessor, many battery management system or battery management functions such as monitoring control can be implemented using the existing system hardware. So in portable system, the load requirement in terms of voltage and current vary widely. Therefore, efficient power conversion and intelligent battery management are essential for reliable operation. Okay, now we discuss about the role of communication channel. Okay, now here, what is the main role of communication channel in BMS? The communication channel in battery management system transfers monitoring and control signals between different parts of the system. As we have seen here in the generalized battery management system, this communication channel is connected to all the parts which will transfer monitoring and control signal between different parts of the system. In simple system, communication may only involve temperature sensing using NTC and identification registers. In smart batteries, detailed digital communication takes place between the battery charger and the system host. Then what do you mean by smart battery system? SBS. That is nothing but to standardize the communication. Duracell and Intel introduced the smart battery system specification in 1994. The goal was to allow batteries of different types and chemistries to communicate in a standardized way. The specification include SMBus, battery data format, charger specifications, and interface to the computer BIOS. Okay, main goal is universal battery communication standard. Okay, this block diagram shows the basic block diagram illustrating the implementation of SBS specifications. Okay, now we are going to see SMBus data and charger levels included. Okay, where we can see SMBus uses a two-wire communication protocol based upon the I2C or I2C. Only one master is active at a time. Okay, the smart battery data specification, smart data specification defines parameters such as voltage, current, temperature, remaining capacity, and state of charge or cycle count. Okay, where this SBD includes total 34 parameters that we are going to discuss in the next slide. Okay, as well as there are three level of chargers. First, level 1, level 2, and level 3. Level 1 provides basic protection. Level 2 allows the battery to control the charger. Level 3 allows the charger to decide the charging algorithm. Okay, although SBus was designed for all the portable products, but in practice it is only used in notebook computers. Okay, standardized communication between battery, charger, and host system enables intelligent power management and improves the system reliability. Okay, now which and all the 34 parameters in SPD. Here you can see that 34 parameters includes electrical measurement, in that voltage, current, temperature, capacity information, remaining capacity, full charge capacity, design capacity, state of information, health and history, identification of the data. Total 34 parameters are included in the SBD. Okay, in the next video, we are going to see the comparison of low end, high end shavers and the two types of the cellular phones. Thank you.